So hi, hello everyone, welcome to the channel. So in this video I'm going to show you how to download a rainfall data as a CSV file format using random sample point generator using Google Earth Engine. So now let's get started. So we're going to download the rainfall data as a CSV file format with latitude, longitude and rainfall data in millimeters. So for the specific study region called Thailand. So to do that, we're going to first load our country's boundary layer into our Earth engine. So for that, we defined a variable called countries. Variable called countries equals to w.feature collection USDOS LSIB simple 2017. So next we have to filter with a specific country. So for that, we defined a variable called ROI. That is our region of interest, that is Thailand. So for that, we defined ROI equals to countries.filter w.filter.eq country name. So we output the layer name as Thailand. Next, to add this layer in Earth Engine, we define map.addLayer ROI. So here ROI represents our region of interest and the curly brackets here represents our default visualization parameter for the specific study area, that is our Thailand country boundary layer, and output the layer name as Thailand. And now to center this particular layer, we define map.centerObject with ROI stating that is our region of interest with a zoom level of 4. So next we're gonna access our CHIRPS data, that is our rainfall data. So for that, we defined a variable called CHIRPS equals to image collection UCSB CHD CHIRPS pendate dot select precipitation. So this is a precipitation band that is available in CHIRPS data, and we're going to filter with a specific timeline starting from 2023 January 1 and 2023 December 31st. And next we have to reduce the image collection to up to 1 by summing all the 365 daily rasters of rainfall data. So for that, we defined a variable called annual CHIRPS equals to CHIRPS.reduced reduce.sum. So this specific function will sum up all the 365 days of rainfall data into a single image as an annual rainfall data. And to visualize the information about it, we're going to define print annual CHIRPS. So next we're going to create our visualization parameter. So to create a visualization parameter for rainfall data, we defined a variable called vis, that is visualization. We're setting with a minimum value of 0 and with a maximum value of around 3500, and we are setting the color palettes. So starting with the lowest level of rainfall and up to the highest level of rainfall. And next we're going to add our annual rainfall map of the research area, that is our Thailand. So for that, we defined map.addLayer annual CHIRPS.clip ROI. ROI really represents our region of interest, that is our Thailand, with the visualization parameter, which refers to our visualization parameter, and output the layer name as annual rainfall. And next we're gonna create our random sample point generator to extract our rainfall data as in a CSV file format. So each of the random sample points will extract the rainfall data for the specific study area. So each of the points will extract latitude, longitude as well as the rainfall data of the specific area. So for that, we defined a variable called variable projection equals to annual CHIRPS.projection. And next we defined variable scale equals to annual CHIRPS.projection dot nominal scale function. So this is a samples annual rainfall image of the random sample points within the boundaries of Thailand. So next the projection and scales to be defined based on the projection of an annual rainfall. So for that, we defined a variable rainfall samples equals to annual CHIRPS.sample, and region here represents our ROI and the projection represents our projection variable. So this specific variable here, and the scale represents our variable scale here, so this specific variable, and the geometries is true. So the projection and scales are to be defined based on projection of the annual rainfall data. So next to add the sample points to the map, we define map.addLayer rainfall samples with the default visualization parameter for our random sample points, and output the layer name as points extracted. And this specific will add our sample points to the map. And next we need to add a properties to our output table. So we can add 3 different properties, that is rainfall in millimeters and longitude and the latitude. So for that, we defined rainfall samples equals to rainfall samples dot map function features, and next we defined a variable called geometry equals to feature dot geometry function dot coordinates. And next we defined our three required table properties, that is rainfall, longitude and latitude. So for that we defined doubly dot number feature dot get precipitation sum. It will gives us a rainfall, and the longitude doubly dot number geometry dot get 0. And similarly for latitude we define doubly dot number geometry dot get 1. So this section transforms the sampled point into a feature with desired properties. So next we define print rainfall samples, print rainfall samples dot limit. So we're gonna we're gonna visualize our rainfall sample data here, and we are setting with a limit of 10. So in order to because we have certain restriction to view the amount of data in Earth Engine, so it can overload the memory here. So in order to avoid that, we're gonna limit the number of data we're gonna visualize it. So for that we define the limits to be 10. So for visualization purpose, we define to view the data, we define this the rainfall samples in the number of 10. So it prints the first 10 sample points along with the rainfall values containing longitude and latitude. At last, we need to export our rainfall data and latitude and longitude as a CSV file format, CSV file format. For that, we defined export.table.to-drive, and we define the collection as rainfall samples, and with the description we set to sample points. And the file format we're going to export is in CSV file format, and the selectors, that is our table properties, will include rainfall, longitude and latitude. So the purpose of this script is to download the rainfall data as a CSV file format with latitude, longitude and rainfall data in millimeters using random sample points in CHIRPS data and visualize it. So now let me show you that. We're going to reset this and we're going to run this code. We're going to click this option called run script. So now let us take a look at the result here. So first let us take a look at this part of the section here, that is in console section. So here you can able to visualize it. We have used only one band, that is our precipitation sum band of CHIRPS data. And next we have to visualize our 10 sample points, if I already mentioned it. So here you can see in the features here, so it has randomly shown us the 10 sample points, so each containing with the latitude, longitude and rainfall for that specific study area. So here similarly we have the second sample point here. You can visualize the result, so with the latitude, longitude and rainfall. So it gives us a random points to visualize the result from the study area. So now let us take a look at this map here. So we're gonna zoom it. Let me zoom to the study area here. So you can able to see here. So now to visualize it, I'm gonna click this option here, toggle full screen view. So now we can able to visualize the entire study area. So it picked the random sample points in our study area of Thailand. So you can see there is 3 different layers that is available here. So one is a point extracted. So there is our random points generated in our for our study area, and similarly this is our rainfall data. So you can take a look at this annual rainfall data, and this is our study area boundary layer with the default visualization parameter included. So from this study area you can able to visualize based on the visualization parameter. I have given a high rainfall areas in red color, and the moderate level of rainfall has been given in yellow and green, and the lowest level of rainfall has been indicated in blue areas. So in the coastal part of the Thailand here, you can able to visualize there is a higher amount of rainfall has been received in this part of the area, and also towards the northeastern part of the areas has a very high amount of rainfall. In this study region, you can able to see that. And now let us download the. You can able to clearly visualize the result of our the rainfall amount in the study area. So higher level of rainfall being received in this part of the areas and towards the northeastern part of the areas. So now let us download this particular data in CSV file format. So to do that, we're gonna navigate to this option here in the task section here. We're gonna click this. So in that, we're gonna visualize this particular task called an unsubmitted task. That is we are gonna export our the rainfall data as a CSV file format. So for that, we're gonna click this option called run. So once you did that, a window pops up saying initiate table export. So the file name is sample points and the file format is CSV, CSV file CSV. So here I'm gonna mention the task name is CS sample points Thailand, and similarly the file name I'm gonna mention it to be sample points Thailand. So once you did that, we're gonna click this option here, run, and it's gonna start export our data to our Google Drive. So it takes only a few minutes to export our data to our Google Drive. So now here you can able to visualize in unsubmitted task. We have exported our sample points Thailand. So now we're gonna visualize the result. So for that, we're gonna click this down arrow button here and we're gonna click this option called open in Drive. So it's gonna open the Google Drive. So here you can able to visualize our sample points Thailand.csv. So you can able to see that we're gonna download this particular data here. So I'm gonna click this option here and click this option called download. So it's going to download the data. So now here I'm going to save this particular data here in the Rainfall CHIRPS folder here. So I'm going to give the name as Rainfall sample points Thailand. So now we're going to save this file here. That is our Rainfall sample points Thailand. We're going to click this save. So now our Rainfall sample points been downloaded. So let me open my Excel. So now I'm going to navigate to my folder location, that is Rainfall CHIRPS. So here you can able to visualize our data. So now we're going to open this Excel here. So we're going to click this Rainfall sample points Thailand. Let me click this. So now here you can able to visualize the result here. The rainfall data is downloaded along with our longitude and latitude information is available here. So we have our rainfall data in millimeters with longitude and latitude properties. So let me get back to our Google Earth engine. So in this video I have shown you how to download the rainfall data as a CSV file format using our random sample point generator using Google Earth engine. So thanks for watching, and please subscribe to our channel and give us a like.